The spherical coordinate system is the last coordinate system we'll be talking about. And it's based on a sphere. And so to represent a vector in spherical coordinates, in this case we have this vector r, then what we need to do is go along the x-axis some distance, then we'll swing in the counterclockwise direction like we do with polar coordinates, and then once we get to this curved surface, we then have to come to the what would be the z-axis, and this would be another circle, half circle in distance. Well, I just need to come down from this z-axis just a little bit along the spherical shell. And so the z-axis is considered to be at 0 degrees for phi, and I'm sorry, and for theta in this case. And if I take a look at the bottom, it's going to be pi degrees. So it's a little bit different because from top to bottom it's pi, but in the circular direction that's 2 pi angle, and if you want to look at it from a equator type direction. Now we're going to do a few things with spherical coordinates, but not much more than what we're going to do with cylindrical, so it's not necessary to get so deep into it. But the two formulas that you're very much going to use, it's the surface area of a sphere and the volume of a sphere. So if I have some sphere, the only thing that I'm really going to worry about is the distance from the center out to the edge, then the surface area of the sphere is 4 pi r squared, and the volume is 4/3 pi r cubed. Now you can find these in the back of your book. They're good to remember. Now there's one other thing that we will be doing with the sphere, and that's when we're going to be integrating along a surface. And so we need to have the differential surface area for our integrals. So the one that we're interested in is in the r direction, and so we're going to be using this differential surface area when we do some problems in chapters 21, 22, and I believe 23. We'll need to use this, and as you notice, it's going to make it so that we're going to be doing multiple integrals to be able to solve problems. So we'll practice this in class. I'll show you how to do it. It's not very difficult, but you do want to remember in this presentation you will need this differential.